Okay, in this video I hope to show you some shortcuts for solving these triangle problems that we've been working on for a while. What I have up on the screen right now are the two special triangles we've been talking about. And I want you to remember that even when we're talking about trig, the size of the triangle is not the most important thing. It's the ratios that we create through similar figures. So as long as I know I have these kind of triangles, the side lengths, the relationships of the side lengths are all going to be consistent. And the reason I bring that up is right now these two triangles have different hypotenuses or hypotenuse. And what I want to do is shrink or somehow change the size of these triangles so that they have the exact same hypotenuse length. And we're going to make that be a length of 1. The reason is 1 is just kind of a nice number, and you're going to see that it allows us to make some connections quite easily in all the different quadrants of a coordinate plane that we've been looking at. So if I look at my 45, 45, 90 triangle, one thing that I can do to kind of shrink this down is simply divide the hypotenuse by itself. Divide it by square root of 2. And that would get 1, which is kind of what I told you I wanted to get already. That should be an equal symbol right there. There we go. But if I do that for one side, I need to do it for all the other sides as well. So I'm going to divide this by square root of 2. And we talked about this a little bit already. This is, to a certain degree, an improper fraction. We don't like roots in our denominator. To change this, you simply would multiply top and bottom by that first denominator. And in doing so, we create the fraction square root of 2 over just the number 2, right? Square root of 2 on the bottom times the other square root of 2 on the bottom gets a square root of 4, which reduces to the number 2. This is the last part there is the number I want you to remember. Yeah, I want you to remember square root of 2 over 2. And so obviously if we would have to do the same thing here, divide this by square root of 2, so we're dividing all the sides by square root of 2, this would also get us that root 2 over 2. So in some ways this kind of looks messier now because yes, we have the hypotenuse of 1, but we've created some complicated fractions perhaps. But you're going to notice it just makes it a little bit easier down the road to make some connections with how all these things fit together. So I want you to practice it this way. If you really prefer just knowing the special triangles themselves, it will work. There's nothing wrong with that. I just want you to give this a shot for a few days at least. All right, next triangle is our 30, 60, 90 triangle. Realize that we use this one to look at both 30 degrees and 60 degrees, so I'm going to be talking about 30 degrees primarily, but the same sides will work for 60 degrees as well. So for this one, I want to divide my hypotenuse by 2 so that I get that length of 1 that I'm looking for. Okay, I want to take half of everything. So I would have to divide this one by 2, and I would divide this one by 2. And here the numbers are a little bit easier to see right away. Just divide everything by 2 and no bad fractions to work with. So again, what we like about this, as we ignore this symbol here, what we like about this is the fact that our hypotenuses are exactly the same. And what we're going to do as I scroll down a little bit is those hypotenuses, or these triangles, are going to fit inside something we call the unit circle. And going to be another good way to think about how these things fit together. Okay, so make sure you do have this reference copied down because I need to erase it as I scroll up here. There we go. Okay. So this is our unit circle. I know it looks a little confusing right now. We're just going to take it kind of a quadrant at a time. So our unit circle will have a radius of 1. Any length that I draw in here, like this, has a radius of 1. But notice that this marking right there, that's our 30 degree marking, or our pi over 6, when they are referencing these angles right here. When they're referencing these angles right here, they're really talking about this angle right there. So that's 30 degrees right now. And what we just created was a triangle, a 30 degree triangle that had a radius of 1, and this side length was 1/2, and this side length ended up being square root of 3 over 2. And so now we can take the side lengths that we have right here, and those become the coordinates of this point here. So square root of 3 over 2 comma 1/2 are the coordinates related to 30 degrees. And I want you to think about what would, in this triangle, what would cosine be? Cosine would be square root of 3 over 2 over 1. Well, dividing by 1 doesn't matter. And then sine of 30 degrees would be 1/2 over 1. Dividing by 1 doesn't matter. And so what we want to kind of see here is that, let me scroll over here just a second, okay? This is cosine of 30 degrees, and this is sine of 30 degrees. Okay, just kind of makes it a little bit easier to find the parts. X is cosine, Y is sine. Let's just see if that pattern kind of continues as we look at some of the other things in this quadrant right here. So I'm going to erase this. Okay, I'm actually going to go up and look at this one right here. Okay, so that's referencing our 60-degree angle, or our pi over 3 angle, and by that we mean this angle right here. So in what we made up above, we said that our radius would be, our radius or hypotenuse would be 1. This was going to be 1/2, and this was going to be square root of 3 over 2. So again, if we think about sine of 60 degrees, sine is opposite over hypotenuse. Dividing by 1 doesn't matter, so square root of 3 over 2 is our sine value. That's the y value that we see for this coordinate. Cosine would be adjacent 1/2 divided by 1. Dividing by 1 doesn't matter, so cosine of 60 degrees is just the x value up there. So again, what we notice is this was cosine and this was sine. X is cosine, y is sine when we think of transferring our original special triangles into these similar triangles that now have a hypotenuse of 1. The unit circle can kind of help us keep track of that. Okay, let's do the one for 45 degrees here. So there's our 45-degree angle right there. We made this be a hypotenuse of 1. And by doing that, we found in our special triangles this was square root of 2 over 2, and this was also square root of 2 over 2. And if you look up above right there, those are the coordinates then for the point that we have here. I think hopefully you're kind of getting the picture here. Square root of 2 divided by 2, square root of 2 over 2, excuse me, divided by hypotenuse 1. Dividing by 1 doesn't matter, so sine, opposite over hypotenuse, would just be square root of 2 over 2. Cosine would also be square root of 2 over 2. Again, x is cosine, y is sine. So that's a basic intro into the first quadrant. And now I want you to compare a lot of things that you see in the other quadrants. Let's look at 150 degrees. If I was to ask you, what is, let's say, cosine of 150 degrees? Oops, that's not what I wanted. That's better. Okay, we say, well, let's measure 150 degrees. Let's measure this angle. We're going to draw a line straight down, and really we're going to be talking about this angle right in there, and that would be 30 degrees. And so we could go through and use the same kind of side lengths that we had for the first couple days that we were studying this, but we could also say, well, we know that in a 30, 60, 90 triangle, if I make my hypotenuse 1, and now it's going to fit in the unit circle, I know that this is going to be a side length of 1/2, and this would be square root of 3 over 2, but because of the quadrant that it's in, we'd have to count it as negative. Well, if you look at the coordinates over here, they are already filled in for us. Okay, the coordinates already tell us those x and y values. Let's see here, undo, there we go. And if we were to think about cosine of 150 degrees, which we use this triangle to reference that, would be adjacent over hypotenuse. Dividing by 1 doesn't matter, so cosine is just negative root 3 over 2, which is the x value right there. If we want to find sine of that angle measure, sine would be 1/2 divided by 1. This doesn't matter. Sine is simply the y value. So whatever quadrant we're looking at, cosine is the x value, and sine is the y value. Cosine goes with x, sine goes with y. And so as you practice some of these questions, if you can go through and kind of visualize, well, what quadrant am I in and what angle is it related to, you're going to see that there's just so many connections, so many related ideas that occur here. So let's just focus on this, 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 and this. If I were to draw triangles connecting those points, they'd all be related to 30 degrees. And if you notice, all the x, y values there, they're all the same, just the signs are slightly different based on the quadrant that it's in. So if I want to look at sine of 30 degrees, that would be 1/2. Sine of 150 would also be 1/2. Those are the y values. But if I did sine of 210, that's going to be -1/2. And sine of 330 is also -1/2. They're all the y values of that related angle. If I were to look at, what are some other related points here? If I were to look at this and this and this, oops, can't draw that low on my iPad. This and this. Okay, those are all, if I were to connect them and drop a line straight down, they'd all be related to 60-degree angles. So if I wanted to know, let's say, cosine of 60 would be 1/2. Cosine of 120 would be -1/2 because now we're in a different quadrant, and so the adjacent sides in this quadrant would be negative, and it's already done for me in the coordinates. Cosine of 240 would also be -1/2, and then cosine of 300 would be +1/2, just because of how the adjacent side would work in all the triangles that I have here. There's a lot of other neat little tricks that we can use to kind of memorize the patterns here. Notice that if we were to look at the typical numbers that we have here, everything is divided by 2. Everything's divided by the number 2. If I look at the x values as I move up the unit circle, x values start with 3, 2, 1, and the y values are just the opposite, 1, 2, 3. And you really could think about taking square roots of all the numerators. Square root of 1 is still 1. So there's lots of different ways to remember some of those patterns, and then they just reflect over, and you make things positive or negative based on the quadrant that it's in. I think at this point, I'm just going to stop here. I'm sure there are going to be questions, and that's a good thing. If you're kind of struggling with some of that, I just encourage you to maybe rewind the video and watch the last 3-4 minutes over again and just try to make sense of some of the connections. And then we'll practice this quite a bit in class.